Okay, let's look at some examples of applying what we've learned about right triangle trigonometry. So I've got 3 examples here. First example, a surveyor is standing 50 feet from the base of a large tree. She measures the angle of elevation to the top of the tree as 71.5 degrees. We want to figure out how tall is the tree. So step 1, if a picture is not there for you, let's draw a picture. So standing there, let's pretend that's the tree. I am no artist. And that makes a right angle, assuming the tree is growing straight up. And the surveyor is standing here, and so when we say angle of elevation, that means the angle from the horizontal up to the line of sight, or from the line of sight down to the horizontal. So that angle is 71.5 degrees. We know that she is standing 50 feet from the base, so the length of this leg is 50 feet. We don't know the other leg. That's what we're trying to find out. Let's call that capital T for tree. And how can we figure that out? Well, from right triangle trig, for the 71.5 degree angle, T is the opposite leg and 50 is the adjacent leg. So I have the opposite leg and I have the adjacent leg. Which trig function used the opposite and the adjacent? Oh yeah, that was tangent, right? SOHCAHTOA. So what we're going to do is let's write a tangent equation, and we'll say the tangent of that angle, which we know is 71.5 degrees, equals the opposite leg, which is T, over the adjacent, which is 50 feet. And now we just need to solve that equation. Now, one thing I want to make sure that you remember, when I say the tan of 71.5, tangent is a function, and this is the argument or the input to this function. So the tangent of 71.5 degrees, this returns to me a value, a number. So basically I'm saying a number is equal to T divided by 50. And we need to solve that equation. Had I given you the equation like, I don't know, 4 equals T over 50, I think everybody would be able to solve that. You'd multiply both sides by 50. That's the opposite of divide by 50. That reduces to 1. So now we have T alone on this side, and then we multiply those and get our answer. So the same idea here. The only problem is we don't know what the tangent of 71.5 is. That's not one of the angles on our unit circle. So we're going to have to use our calculator and have the calculator tell us what's the tangent of 71.5 degrees. And then we'll multiply that answer times 50. So I usually wait till the end to grab my calculator. So let's multiply both sides by 50. And then 50 over 50 is 1. So then we're going to wind up with T is equal to approximately. Now I'll grab my calculator and I'm going to do 50 times the tangent of 71.5 degrees. So 50 times, find the tangent button, 71.5. Now it's supposed to be in degrees. I better make sure my calculator is in degree mode, not radian mode. So I'm going to press the mode button, and if I scroll down here, I notice radian is highlighted. So I'm going to hit the right arrow to highlight degree, press enter. Now degree is active, so now I can press second, quit. Now I know I'm in degrees, so 50 times the tangent of 71.5 degrees, press enter. 149, we'll round it to 2 decimals, let's say, 0.43. So 149.43. Let's get there. And remember that the units here were in feet, so my final answer, let's say 149.43 feet. And that's how tall the tree is. All right, let's try another example. You're standing near a 30-foot tall flagpole. So you know how tall the flagpole is. It's exactly 30 feet. You measure the angle of elevation to the top of the pole. Now we're going to disregard the difference between where your eyes are off the ground, and let's just keep this simple. Let's just say your eyes are at ground level when you measure this angle of elevation. So maybe you decide to lay down and use some kind of a surveyor's tool to measure that angle of elevation. How far are you standing from the flagpole? All right, once again, let's draw a picture. We have a flagpole here. We know the height of the flagpole, 30 feet. We do not know how far you are away from that, but the angle of elevation from the ground, since it didn't specify otherwise, is 30 degrees. So that angle there is 30 degrees. Sometimes problems will get more specific and they'll say that, you know, your eyes are 6 feet off the ground or 5 feet off the ground, or they'll give you something like that. And so then in that case, let me draw a quick picture. In that case, you're standing there, so now what we have to do is make our right triangle there. So we would subtract, let's say this was 5 feet off the ground, we would subtract 5 from the total height of the flagpole, and then that would be 25. So just read it carefully and decide what they're giving you. And if they're not specific, you can assume that angle is from the ground. All right, so we've got everything labeled here. How about a right angle? And we're trying to find how far you are standing from the flagpole. Let's just call that X in our picture. So we need to figure out X. Well, once again, what do we have? From the 30-degree angle, we have the opposite and the adjacent. So I'm going to want to write a tangent function. The tangent of 30 degrees equals the opposite, 30, over the adjacent, which is X. Now this is almost the same equation, except notice the variable we're trying to solve for is in the denominator. So how do we deal with that? Once again, sometimes it helps to think of an easier problem like 2 equals 30 over X. What would you do to solve that? Well, just like we did before, we could think of it as, well, let's multiply both sides by X, cancel those. So now I have 2 times X equals 30. And then I could divide both sides by 2, and then I'll get X equals my answer. It seems like a lot of work, though. There's another way to think about it. When you have a variable in the denominator, maybe think of it this way. 2 is equal to 30 over X. What if we made it 2 over 1? And then you could think, oh, it's a proportion I can cross multiply. So 2x is equal to 30. And then divide by 2, you get x equals 15. It's another way to think about it. A third way to think about it is understanding how proportions work. And 2 over 1 equals 30 over x. So that means that x over 1 equals 30 over 2. I can actually just switch those and I'll get the same proportion. So that's what I usually do is the x goes to the other side, the 2 goes underneath. Whatever way makes the most sense to you, solve it that way. So now we're ready to solve this. So it turns out then x is going to equal 30 divided by the tangent of 30. Now this angle is on our unit circle, and we do know what the tangent of 30 degrees is. Do that over on the side. The tangent of 30 is the sine of 30 over the cosine of 30. The sine is 1/2. The cosine is root 3 over 2. The 2's cancel. So we get 1 over root 3, and then we always rationalized and got root 3 over 3. So we could actually get an exact answer here if we wanted, but for these real-life applications, we generally want a number, and we'll use a calculator to get a decimal approximation. So let's grab our calculator, and let's do 30 divided by tangent of 30. And I already know I'm in degree mode, so I don't have to check that again. And I get 51.96. So if I wanted to round that to the nearest tenth, it would actually round up to 52.0. So I'll just use that, 52.0. This didn't specify. So x is approximately, well, here it was 51.96. So I'm going to say 52.0 feet. And that's how far you're standing away from the flagpole. If we wanted the exact answer, then we would do 30 divided by Actually, I'm going to leave it as 1 over root 3. I'm not going to rationalize, because then dividing by 1 over root 3 is the same as multiplying by root 3 over 1. And so the exact answer should be 30 times the square root of 3. Let me check my calculator. What's 30 times the square root of 3? Oh, it's that exact same number. Okay, so sometimes in problems you'll get angles that you can use numbers from the unit circle, and sometimes you'll just have to use your calculator no matter what. Let's look at one last example. You're 150 yards from a river. Instead of walking directly to the river, you decide to walk on an angle, and you walk in a straight line 400 yards to get to the river's edge. Find the acute angle between this path and the river's edge. All right, so this picture is going to be slightly more complicated. So let's say there's our river, and you're standing right here. And you're 150 yards from the river. So to the bank of the river there is 150 yards. But you decide not to walk straight that way. I don't know, you need some more exercise. Instead, you walk at an angle here, and you go way over here. And that's a total of 400 yards. Okay, where's our right angle? Our right angle is going to be here. And it's asking for the acute angle between the path you walked and the river's edge. So that's this angle over here. Let's call that theta. All right, this time I don't have the angle, but I do have the opposite leg, and I have the hypotenuse. Which trig function used opposite leg and hypotenuse? That was the sine function. So I can say the sine of theta equals opposite, which is 150 yards, over hypotenuse, which is 400 yards. So now, even if I reduce that down, I could divide by 10, then I could divide out of 5, I would get 3/8. So if you wanted, you could simplify and use that. I generally just leave the big numbers, because if I reduce wrong, then my answer is going to be wrong anyway. But what I'm trying to get at is 3/8 is not a ratio that's on our unit circle. So I can't say, oh, it's going to be 30 degrees or 60 degrees or 45 degrees. I can't figure that out. So I'm going to have to use my calculator. But this time, I don't know what theta is. So I can't just type in sine of an angle. I have to figure out, I have to almost do the opposite or the inverse of the sine function to get my answer. And then indeed, we did inverse functions way back at the beginning of the year. In order for me to find theta, I need to do the inverse of sine, which I'm going to write like this, of 150 over 400. And that should give me the angle. So kind of like if we said, what's, if f of x equals whatever, 2x plus 3, and then we figured out the inverse function, f inverse of x. And so that's what I'm doing, is I have to come up with the inverse function. Now, shortly, we're going to start talking about the inverses of all these trig functions. We'll graph the trig functions before we talk about their inverses, but we can still use the calculator to get a number for this answer. So on my calculator, if you look at your sine button, probably above the sine key on most scientific calculators is a sine inverse, or that sine -1. It's important to understand that doesn't mean, it's not like a number to the negative first power. Over here and point, this is a common mistake students make. If I said, what's 5 to the negative first power, you'd say, oh, that's 1 over 5. But if I say a function with a -1, that means the inverse of the function f. Okay, so find that button, the inverse sine button on your calculator, and that's second sine. And now I want to type in 150 divided by 400. So instead of giving me the ratio, so the sine takes an angle and gives you a ratio, a number, the inverse sine takes that ratio or that number and gives you an angle. And I'm in degree mode, so that's 22.0 degrees. So I know that the angle between the river and my path is approximately 22.0 degrees. And there you have it.